Hey guys, and how's it going? This is part 4 of the Mercedes SSK kit car replica, whatever you want to call it, build, 1929 replica. And making a lot of progress. Again, this is part 4. If you haven't seen part 3, 2, or 1, go check them out. But I noticed when I cleaned up and did all the brakes and everything, I'm missing a strut. So all the Mustang 2s and the Pintos, all that stuff back in the 80s, late 70s had a strut bar that would come from here on the cross member back to the frame, and then it had like shock absorbers in it, so it would allow for the suspension to go up and down and travel. So it looks like there are 4 holes here on the frame. That's what it's for, and it looks like probably like a 3-inch bolt's needed. But I went through the parts pile that I got with the car, and I found these are the plates for that. Have to be, so I need to get these cleaned up, clean up the welds a little bit, get them brushed down, core sealed with my famous rust converter, and then I'll paint them black. And then here are the strut arms that need to be cleaned up, so I'll get these all wire brushed, cleaned, and need to find another nut for this side. These are real hard. The bushings should be soft. So I sourced these neoprene bushings online. I think I got them on Amazon.
This is Dr. E.L. Gibson, Enterprise, Alabama, 83 years old, still practicing medicine. He drives a Ford Pinto, but that's not surprising. Doc Gibson started out in a rugged, reliable Ford car over half a century ago.
First car I owned was a Ford Model T, like that one there. Used it to make my house calls. That car took some licking, but it got me where I had to get.
It's that same kind of car we had in mind when we built today's Ford Pinto, to stand up to rough roads, to take the worry out of the mud. We built Ford Pinto to be a rugged, reliable, basic car, just like the one Doc Gibson started out with 60 years ago. When you get back to basics, you get back to Ford. Pinto for $73 at your Ford dealers.
All the struts and brackets are core sealed, rust converter, and also painted up, and it's drying in the sun right now. I think I'm going to move on to making some brake line tabs. On the end of the brake line, so here's the front caliper. On the end of the brake line, the flexible, you need to go into the hard line that I'll be running out of NiCopp 3/16" brake line. But there are no tabs on this frame, so I was able to source these stamped out pieces of metal that are the tabs. And how this works is just like pretty much any car out there, is that the brake line goes through this tab, and then on the back you have this locking that'll just wedge it in there and lock it on. So I have to put tabs, and I'm thinking probably this location right here, there's no interference with the suspension and it's down all the way. I'll put one of the tabs right here, and then in the back I have the flex hose that allows the flex from the brake lines, the hard brake lines that go from the passenger side wheel to the driver's side wheel. This is hard line in here, and then you typically have a block here in the middle with a flexible line that goes onto the frame. So this block is going to bring me out on this side. So what I think I'm going to do is flip this around, and then I'll make my mounting tab right here on the frame, right about here, and that'll be a great location to go ahead and mount this one. So I need to get the welder out, weld 3 tabs onto in the front, 1 in the back, and that'll scratch that off the list. Brake tabs are welded in, installed. That turned out really nice, both sides. And then also the rear tab welded in and installed. Very nice. New front struts are in. 8 bolts in this mounting plate that I found in the pile of parts. And I got my new neoprene shocks on there, and looking really good. Next thing is, here's the Pinto fuel tank. Needs to have a date with the pressure washer here in a little bit, and that's good to go. And I looked at the inside's spotless, so Keith must have definitely drained all the fuel out. It's got some dirt in here because of the opening for the fuel intake has been left open, but I'll just flush it out. The best thing I found to flush out gas tanks is just use gasoline, flush it out, put maybe a couple quarts in, slosh it around, dump it out. So it's just dirt, but it looks like bare steel inside. Excellent. That's great news. Also with the gas tank, those of you that are older and lived through the 70s, you remember that the Pinto had an issue with rear end collisions, and this gas tank would rupture. What would happen is it would, from rear impact, the gas tank would push forward and go up against the differential in the back, the bolts and stuff, and rupture and just blow fuel all over the place. And a lot of people died. They estimate at least 500 people, as many as 2,000 died in a fiery crash. So all the Pintos were recalled. This little plastic shield, these are the straps that hold the tank up to the body. This little plastic shield, when they did crash tests after they installed this, 8 out of 8 crash tests, there was no explosion by putting this little plastic shield in. And the story goes that the engineers didn't want to tell Lee Iacocca, who was the head of Ford at that time, that this shield was going to cost another $11, and that would put him over the $2,000 sale price.
1. Iacocca insisted that the Pinto could not weigh more than 2,000 pounds. And 2. It could not cost more than $2,000. Just like with his 56-56 campaign, Lee Iacocca had a hankering for number symmetry. The so-called limits of 2,000 meant that even an $11 per car fix was completely out of the question.
Definitely make sure that that shield goes back in along with the tank straps after I get this all cleaned up. Here's the original dual master cylinder out of the Pinto, and then here's the valve. So the circuits typically on a dual master cylinder is that you have one line is the rear brakes, one line is the front brakes. So in the event that a line gets broken or rusted out, or one of the cylinder seals fail, at least when you step on the brakes, you'll have some brakes. Either the front brakes will still work or the rear brakes will still work. I have a friend that has a 60s Bronco and it has a single master cylinder, so I'm urging him right now to convert to a dual master cylinder and split it off into 2 circuits. This has disc brakes on the front and drums on the back. Most of your braking is like 85-90% of your braking comes from the front disc brakes, so that's why a lot of the cars back then had drum brakes in the back. So sorry, losing my voice here a little bit, but anyway, this is a manifold, and I would assume this has a proportioning valve in it that applies, the proper amount of fluid to the front and the rear brakes, since you're using combination disc brakes and drum brakes in the rear. On my hot rod builds in the past, you use a proportioning valve whenever you do that, and residual pressure valves. So there's probably residual pressure valve in here also. So you usually do that on the back and the front, and then you go out on a dirt road, slam on the brakes, and adjust the brakes with a knob on a brake proportioner. So hopefully, I believe this just handles all that, the residual pressure for the disc brakes in the front, and then also the brake proportioning, so it gets the right amount of pressure front to rear. Houston, we have a problem. There's no way this gas tank's going to fit in here. Who knows where this gas tank came from? This is not a Pinto fuel tank, or else maybe it was from a Pinto wagon, maybe a bigger fuel tank. So, got to figure this out. But I have built Model A hot rods in the past where I've used pretty much like a Chevy rear pickup truck gas tank. And I think that's what I'm going to do. I'll have the correct dimensions here. So here's the fuel tank that I'll be using. I'll get this on order and this will fit up underneath. And this is the same fuel tank I used on my 29 Ford Model A with the Cummins turbo diesel in it. That's on my playlist. If you want to go see it, check out my other playlist. But I've had great luck with that tank, so I'm going to go ahead and order that from Danny's Rod Shop right now. Alright, went ahead and installed the dual master cylinder for the brakes. I have my manifold and my proportioner valve, which is in the top of this assembly. Drilled holes through the side bracket, mounted it here so it's nice and sturdy. Ran my NiCopp, which is nickel copper 3/16" brake lines down to the manifold, and this is the rear circuit, this is the front circuit, and then I have two lines going to the left front caliper and then the right front caliper, and then on the other side here, this is the rear going to the rear. Alright, so what's nice about the nickel copper is it's easily bendable. And what I'm going to do next is tack these down. I have stainless steel 3/16" brake line clamps that just go right into the frame, and that'll secure everything down up in the front. I was able to bring the lines out and then curve them into the weld-on tab that I did for the fitting for the brake hose going to the caliper, and then just roughly bent this in place, and I'll tack this down with the clamps and then secure this all together, and that's going to be a nice installation. So let's go on the bench and I'll show you how to do brake line flares. So there are a couple different type flares. You have a standard flare, which you use like in low pressure gas, copper line, that sort of thing. Maybe in your RV, that's just a regular flare. And then for high pressure, you have a double flare, which is a special tool to do a double flare. And then and that's most of the American cars, like the Fords, Chrysler, Chevys, I find, are a double flare. And then for the Volkswagens I've done, the Volkswagens use a bubble flare. So the difference is the clamps are pretty much all the same. The clamping bracket's pretty much all the same, except for these dies. These dies are different. You see how deep that is? That's for a bubble flare for like a Volkswagen. And then you have the regular dies for, if you can see that, I'll zoom in on that a little bit. And this is for a double flare. So this car, these brake lines require double flares, so let's go ahead and show you how to do it. So this is the nickel copper brake line that I like using, 3/16", made out of nickel and copper. It's called NiCopp for short. And it's easily bendable, so all the bends that I did, you can just bend by hand. It will not kink, so you can go different directions with it. Really nice to work with. Just get a standard tubing cutter, and I'll put the link in the description for the NiCopp. Like a 25-foot roll is pretty economical. But if you're replacing disintegrated brake lines on an older vehicle like I did the Volkswagen Thing project, the folks that follow me on my channel saw me just take the brake lines that were just crumbling in my hands and replaced them with all the NiCopp brake line. But just mark what you need. Use a standard tubing cutter you can get at Home Depot or Lowe's. This is an Irwin, works pretty good. I think I got this at Home Depot for cutting 1/2 inch, 3/4 inch copper water lines. So just go back in the plumbing department and you'll see that. And what you're going to do is to cut this, those of you that haven't done this before, is you put it into the fitting right there. And what you're going to do is spin it around, turn the knob a little bit, spin it around, turn the knob a little more, spin it around, and eventually you're going to tighten the knob and you have a nice clean cut without any jagged edges. So do not use a hacksaw something like that to cut these. Don't do that. And then to prep it for the double flare, you'll see inside here now it's a little bit rough. So there is a deburring tool that you can buy. I like just using like a 1/4 inch or maybe a 5/16 inch drill bit, and then run it in the tip here a little bit. And that cleans up a nice little edge on there. Okay, so the next step is I find it, put the clamp in a vise, because it's really hard to hold this. And then depending on your tubing size, it's got 3/8 and 1/4 inch and so on. So what you're going to do is put that in the clamp. And then here's the die that we're going to use for the double flare. And the shoulder distance here, the thickness, is the gauge you want to use for how much of the copper line protrudes out. So that's about right. So I'm going to put this over here, clamp this on, clamp my bottom part. And this needs to be really tight. So you could use the bar from the clamp. I just like using a crescent wrench to do this and get it good and tight down on there, else when you push on it to do the flare, that line will start pushing out the other side, and that's not good. So get that good tight. Next thing is we're going to put a little bit of oil. Just put like a couple drops on the die, lubrication. I want to put the die in the center of the copper line. And then the clamping tool is going to go on. Like so. Thread this out, and then it turns, and then these little wings kind of clamp onto the main channel clamp. And now you're going to tighten, and you want to tighten until this die goes flat with the clamping bar. Back off the clamp. Drop the thing on the ground, the handle. Thread that out, and then I usually take this off. And now you want to remove the die. Sometimes it might stick a little bit. Just take a small screwdriver, kind of work your way around it. And now the die just came out. And I'll see if I can get a close-up. Now you can see the flare on here is almost like a little bubble. Almost looks like a bubble flare, but it's not. But now what we want to do is it's flared in that direction, flared out on the back, and now we want to basically take this and push that in to make the second flare, thus the double flare. So don't take it out of your clamp, put this back on again, run that tip down in there. Run that around, we're creating the double flare now. So you have two surfaces that will seal when we put this into the brake manifold. Now you can undo your clamp. And there's my double flare. Put your fitting on before you flare. In this case I didn't have the other end flared yet. But now look how nice that is. You've got yourself a double flare. And the fitting's on there, and that's ready to go. So pretty simple. Good nice surface in there. The other thing I like to do is put a couple little drops of oil on the threads here before I screw it in. So next I'll show you the clamps I like using. And I'll put the link on the description for the flaring tools, the Amazon links for the double flare, and then if you have like a European, like you need a bubble flare, I'll put also a link for the bubble flaring tool on Amazon. They're pretty economical. But here's the clamps I like using, stainless steel brake line clamps. So what I'm going to do is just put that up against like that and then clamp it, and then I like using pop rivets, so just drill an 1/8" hole and then put a pop rivet in, and then just use aluminum ones. Anytime you need to remove it, just take a drill bit and you'll drill them right out real easy. But usually you don't have to move them once they're clamped. So I'll do that every foot or so on the car, and that should wrap up the brake project. And here's the brake line all cleaned up, straightened up, and held down with the retaining clips. Hey guys, in the last video I had a couple comments when I installed the drive shaft, is that if I check the pinion angle as compared to the transmission angle and the engine angle. And there's different ways of doing this, but yes, I did check it, and I'll show you a couple ways on how to do it. But so here's my engine, excuse the crude drawing here, the engine and the transmission, and here's my output shaft. And right now I'm aimed about, I think it's 8 degrees down low. So here's my center line of the transmission. And then I have my rear end in here with a pinion, and this is where your U-joint's going to go right in front here. And I have it aimed up also the same degree. So the idea is I want this to be parallel. I don't want this nose of the rear end to be pointing down. I want it to be parallel. So I can take a measurement best I can off of the transmission. And in my case, I think I'm like at 8 degrees, something like that. And then if I go back to the third member for the pinion connected to the U-joint, I'm also 8 degrees in that direction. So that's kind of what I'm at right now. So I'm fairly parallel within a degree of this, and then naturally here's your output shaft going to come on here. Here's your U-joint, here's your U-joint, and then your drive shaft's going to go in between here, like so. So I'm in good shape, shouldn't have any vibration, but if you are building a car, or if you notice vibration in the shift lever, you might want to get underneath the car and check this out. So 2 different ways of measuring the angle. I have this old magnetic protractor angle locator, which I've actually used even on building the deck and stuff in my house, but then that gives you the angle. I use that a lot. But if you want to go high tech, there's a clinometer, or however you would call it, and I could lay the phone and actually give me the angles of where I'm at, and that's how I measured it. So just make sure if you have a phone case on, your buttons aren't sticking out, get an accurate reading, maybe take the case off. But this thing is amazing, and it's just an app. This is an Apple phone, and this is an app to measure the angles. So I found a flat spot on the rear end, and then also a flat spot on the transmission. The other thing you do is do it on this angle like this. And I'm finding roughly a flat spot right here on the transmission that's in line with the output shaft. And if I go up just a tad, I'm about 8 degrees, which is really cool. And then if I come back here, which is tougher to do, trying to find a flat spot on it. If I go right here, get this cable out of the way, and that looks like fairly good location right there. So my transmission is 8 degrees down. My rear end pinion angle is 8 degrees up. And so I'm parallel with the transmission, so the output shaft should be fine, no vibration. The other thing this thing does, which is really cool, is it's also a level. So use this once in a while, but pretty cool application for your iPhone, or I'm sure Android also has it. If the pinion angle is not correct and you are getting vibration, the way to correct that is that you undo the shackle bolts on the axle, and you should be able to most likely rotate the pinion or the rear end slightly to get the angle that you need. If you follow my channel, my other hot rod builds, my Model A hot rods where I built the frame and everything, I used a 4-bar suspension on it. So the 2 bars on either side have an adjustment where I can adjust in or out, and then that will turn my rear end to give me the correct pinion angles. Last night I put the steering column onto the brackets of the frame and trying to mock this up, seeing what angles I need. And right here is my steering box down in here. And then this is the standard Pinto shaft that comes up into a universal joint. But the challenge is I need to get from here up to the steering shaft. And the hot rods I usually build, or the car builds, I usually use a double D rod. But I'm going to have to modify this shaft to go to a double D with a universal joint. Come up in here with a pillow bearing and then shoot right up to the steering column. That should be fine. So I need to get some parts on order. So as soon as I get the parts in, I'll do a video on how to do that. But a lot of the hot rodders and custom car makers that you see on TV and stuff are using double D steering column, usually about a 3/4 inch, and then sometimes maybe a 1 inch. But so I'll adapt both ends of the steering column and the steering box joint here, leg, to double D, and then we'll run up through here, and that should work really well. And fortunately, this metal steel plate was welded on from the factory back in 1986, and I'm assuming this is where I'm going to mount my my pillow bearing for the 3/4 inch double D steering rod. Going to my checklist here on my new fancy whiteboard that I mounted in the garage, and I keep track of what in the heck's going on here. But the goal is to have a rolling chassis where I can actually drive the chassis without the body and all the gingerbread on it around the neighborhood for testing. But here's my list. The brakes, I got that pretty much done. Steering linkage, I get the brake pedal, gas pedal, clutch cable. The clutch has already been replaced. I just need to do the cable and the pedal. Today I'm going to tackle the timing belt, hoses, thermostat, alternator. I have to make a firewall. I have to make the firewall top cover on the battery box. This is the section up here. I need to make a metal plate out of 18 gauge, and then the battery's going to recess in here. And I think I'm going to put my ignition Duraspark 2 ignition box right here or on the firewall. And then I have to do my fuel tank yet, which is on order, waiting on that to come in. And then my ignition, got it on there in pieces on the floor. That's ready to go. I have a brand new 12 circuit GM fuse block with modern fuses and silicone wire, which they didn't have back in 1986 or 1980. Steering wheel adapter. In the parts, I did get a real nice walnut steering wheel that'll go really good with the car, but I need the adapter to a Ford steering shaft, so that's on order. And then I just ordered the seat tracks for the 2 bucket seats that are going to bolt down through the floor pan and then into this framework here that they have, I would assume. I need to get the radiator mount done. Just 2 brackets on each side, get the radiator mounted along with the new hoses. And then I'm going to have an electric fan on this car, which probably didn't have many of them back in 1980. But electric fan's much more efficient, so I'm going to pull off the existing blade and put that on. So I got a little ways to go here, but hopefully knock this out in the next week or so. Alright, so time to tackle the timing belt. That kind of makes sense, I guess. But if you have an overhead cam engine, which most likely probably you do, you might want to check and make sure that your belt is current and it's not ready to break. There are ratings, Google it, look it up. Usually it's so many years or so many miles. Some belts are good for 100,000 miles. This one's rated at, I think, 50,000 miles, something like that I found on the interweb. But if that belt breaks, it's a rubber belt, if it breaks, this is an invasive motor. So it means the cam might stop in a position where the valves are sticking down out of the head. And when the pistons come up, they're going to hit it. And when that happens, that's a bad thing. You've blown your motor. And if you look on Craigslist, probably in the junkyard, there's tons of engines that were blown by people just not doing preventative maintenance and changing out the timing belts. The other thing is you may have a steel timing belt, like my wife's Honda CR-V is a 2008. It doesn't have a rubber timing belt. It has a steel one, like a chain link chain that goes around it. So you don't have to replace that one. But please research, check out your car, see how many miles you got on it, Google it, whatever. and see if you need to change a timing belt. If you can't do it yourself, take it to somebody that can. It's a nominal process, but it may save your motor. So I have the pulley, the crank pulley off. I took the pulley off up here. I took all the belts off. I have the hoses, which I'm going to replace these hoses anyway. And then on this motor, which is a really good motor, this 2.3 and the predecessor, the 2.0 Ford motor, a lot of these engines went into race cars, and they use them for circle track racing and stuff. So
with a reputation for rugged reliability, the compact 4-cylinder Pinto could be tuned for road or track. It had huge racing success in the 1960s and 70s. Many were driven to destruction, so now they're thin on the ground. So classic motorsport enthusiasts, especially Ford drivers, are always on the lookout for running engines.
There's a lot of aftermarket stuff that I could get for it. I could put headers on it. I could put an intake manifold on it with a new one with dual Webers. You could really hot rod it up and get it up to maybe even 150 horsepower, 160 horsepower. Also variable timing on the cam. You can get that. So, but I'm going to keep this one stock for now. Maybe do the headers later down the road, maybe a dual import. So the parts are on this. You have the belt, you have the spring, and then you have the tensioner. And this tensioner looks like it's toast too. So in the kit that I get, you get the belt and the tensioner. So the next thing is to get this cleaned up and then release the spring here, and then release that nut, and it'll take the tensioner out. But you can see the timing marks here. So there's two ways of timing or putting the belt on, and that's the relative method or the absolute method, if you look it up. Absolute means I'm going to line up the moons and the mountains. There's a little timing mark right here, and I see the notch. It just happens I'm almost right on time here. And then here's an indicator right here. So if I line that up along with the mark here on the crank, and also the indicator on the crank itself, I'll be top dead center on cylinder number 1, and then I can pull the belt off, make sure I don't move any of the pulleys while I'm putting the new belt on. And you want to put on this belt on this side. All right, so I cranked over the motor just a tad. You can see I have my notch here, my mountaintop faced into this notch here. I have my indicator, piece of metal that they have on here, pointed towards the metal, like the bump that's in the camshaft pulley right here. I have my belt on, nice and snug down here, nice and snug up there. All the teeth are lining up. I still have my absolute mark there, my mark here, mark there, and good to go. Time to release the tensioner. Alright, the tensioner's released. Good tension on the belt. Again, double checking all my marks. My mark on the cam, mark on the other pulley here, identical. All the teeth are in place. And on the crank is still in the position, top dead center. Belt looks really good. Now what I'm going to do is I'll just turn it over by hand, probably a couple times, just make sure the belt's seated properly, and then I'll put the cover on and we're good to go. But I'm glad I changed the belt because the other one was toast. Note is when you take this washer off of the crank, it is concave, so you want to make sure that it's angled inwards, and most likely you'll see the marks of the teeth on here of the belt. So that goes on first, then put the pulley on. Alright, a lot of progress this week. I think that's enough for the video. Let's go ahead and wrap it up. Please like, share, and subscribe. I know you want to subscribe, hit the subscribe button. And thanks for watching.